Let's solve another problem using counting principle of multiplication. So what we have to do here, new cloud flag is to be designed with 6 vertical strips using some or all of the colors yellow, green, blue and red. In how many ways can this be done so that no two adjacent strips have the same color? So let's solve it. I do have to design this flag with 6 strips. 1, 2, 3, 4, 5. Let's name them as S1, S2, S3, 4, 5, and 6. And the color I have yellow, green, red, and blue. And what are the condition given? No two adjacent strips have the same color. Okay, so any of the two adjacent cannot be, which means S1 and S2 cannot be of the same color. Likewise, S2 or S3, S3, S4, and so on and so forth. So let's solve this problem. So start with, let's say I'm just coloring this first strip as yellow. So how many ways I can, before making it yellow, let's see how many different ways I can color first strip. I have 4 different choices, so I can color them in 4 different ways. I can color them in 4 different ways. But let's assume first I'm making a color yellow, the first strip. So by the condition given, the second strip cannot be colored by yellow because no two adjacent strips will have same color. So the second, if I need to color the second strip, what are the options left? So these 3 options are for choosing. These 3 options are left from which I can choose the second position, the second strip. So it would be 3 different ways I can color strip, second strip. Now I need to color third strip. Let's say I have colored S2 as green. So I cannot color S3 as green, but yellow which I colored the first one, that can be used to color S3. So how many options left for me to color S3? I do have 3 options. What are those? I do have yellow, red, and blue. So how many different ways I can color them? I can color them in 3 different ways. Now coming to, let's say I color them as red. So coming to S4, how many different ways I can color? And how many options are left? I cannot color red, S4 as red because S3 already it's red. So how many options are left? I do have yellow and green, which S1 and S3 already colored. So that can further be used to color S4. So how many options I have left? Again, I do have 3 options left to color S4. What are those? Those are yellow, green, and blue. So I can color S4 as 3 different ways. Likewise, I can color S5 as 3 different ways, and S6 also 3 different ways. So in total, how many different ways I can color or I can design this flag using the counting principle of multiplication? It's very simple. It should be 4 times 3, 5 times 3, 6 should be 4 times 3 power 5. So this is the total number of ways to design this flag for that particular trial. Now we'll be discussing permutation. So what exactly this permutation is. Very interesting uh, applications are there of permutation and combination. But before we get into that, we should know what exactly this permutation and what is the formula of permutation, how that is derived. So before we get into that, we should know what exactly this permutation is. It's basically number of ways to choose and arrange. So this is important part here. Choose and arrange are distinct objects from a set of n distinct objects. So basically the number of ways you can choose and arrange are distinct objects from a set of n distinct objects, which can be derived or which is denoted by n permutes r. From n distinct objects, we are choosing and arranging r distinct objects, and which is denoted, which is basically the formula of npr is n factorial upon n minus r factorial. But you must be curious how this is derived. So we'll come to that. We'll come to this derivation, but before that, let's try to derive through an example. Let's understand how we can get to this particular formula. And permutation is basically, let me give an example. I need to form a cricket team of 11 players. For a squad of, let's say, 22 odd players, I need to choose 11 players from a squad of total 22 cricketers. And then, see, if I simply choose it, then it's going to be a combination. But if I need to choose and then, let's say, arrange them in a batting order, so then it has to be treated as a permutation problem. Basically, I'll be choosing 11 player from a squad of 22 and then arranging in a batting order. So in permutation, the order matters. We'll understand more in subsequent example, so it will be much more clear. Before that, as I said, so we must be curious where this come from. If I need to choose r distinct objects from a set of n distinct objects, I'm saying the total number of ways it would be n factorial upon n minus r factorial. So let me solve this through an examples. I do have 5 letters A, B, C, D, and E, and have been asked to form 3-lettered words. So how many such 3-lettered words I can form out of this 5-letter? It's very interesting problem. So I need to form 3-letter words. So how many such 3-letter words I can form out of these 5 letters? So how can I do that? Let's, we already have, we already know the branching method. So let's begin with that. So of all the 3-letter words, let's say, see how many such 3-letter words can we form starting with A. So I'm starting with A. See, if I start with A, the first position is A. The second position can be filled with 4 different remaining letters. It could be, let's say, C, B, E, or D. So the second position can be filled with 4 different ways. Now, let's say second position I'm selecting C. So third position can be filled with three different ways. It could be B, let's say B and E. So my three-letter word is formed. This is just one of the numbers. So how many such numbers? Likewise, if I choose a different part, let's say instead of C, I'm choosing B. So A, B, I do have three options here. If I choose another part, I do have three options, So the first position can be filled four different ways. Second position, say starting with A, and third position can be filled in three different ways. So how many such three-letter word can be formed starting with A? So starting with A, we can form 4 times 3. And so starting position can be any one of the 5 letters. So for all, likewise, B, we will have 4 times 3. E will have 4 times 3. So total 3-lettered words can be formed. Definitely it would be 5 times 4 times 3. Yeah, this much. So this is the total number of 3-lettered word can be formed out of 5. Now, instead of 5 letter, let's say you are given 6 letters. A, B, C, D, E, and F. And you have been asked to form 3-letter words. So how many such words I can form? Let's say starting with first, the second position can be filled with 5 different ways. So it should be 5 different ways. Let's say B, C, D, E, and then third position, let's say D. So it can be filled with 4 different ways. It has to be, if I take this part, C, B, E, and F. So I need to form 3-letter words, so I'll not go further down. Likewise, if I take different paths, so it has to be all 4. So how many such 3-letter words I can form with A? It has to be. So with A, we have 5 times 4. For B as well, 5 times 4. Till F, 5 times 4. So total number of 3-letter words I can form 1, 2, 3, 4, 5, 6 positions. So it has to be 6 times 5 times 4. Now we'll see these two problems closely. Here I have 5 distinct letters. I have been asked to form 3-letter words. So this many number of word I can form. Here I do have 6 distinct letters. I have been asked to form 3-letter word. So here I have 6 times 5 times 4. Now, if we can generalize this, I do have n distinct words. I need to choose. I need to find how many odd-letter words can be formed. So how can we do that? So basically, one thing is very clear here. So I need to choose N, P, R. So basically, I need to form odd-lettered words from N letter. N is number of letters. I need to form how many odd-lettered words can be formed. So how can you get that? So basically, which would be, here N is, for this problem, I can take N as 6 and R as 3 because I have 6 distinct letters. I need to form 3-letter words. So here 6 P 3 I can write. So how long I'm coming? So I'm just back counting. So from starting from 6, I'm coming 2 level down here. For 3, I'm coming 2 level down here. Same here, I have 5. Since I need 3, so I need to come 2 level down here. So for here, so it has to be, let's say, since it's 6, it's coming 6, 5, 4. Since it's n is here, n here is 5, r here is 3. So I'm coming 2 level down here. Let's say, so if it's n and I'm choosing r, it has to be n times n minus 1, n minus 2 times n minus r plus 1. Okay, let me erase it. So what have you seen? If we have 6 distinct letters and I've been asked to form 3-lettered word, how many such distinct word I can form? 6 times, 5 times 4. If I do a 5, I need to form 3-lettered words, I can form 5 times 4 times 3. So there is a common thing here. So for 6, it has to be likewise. Here, I need to choose R from n distinct, let's say, letters. So it will definitely go n minus R plus 1. Just think through. What is R here? R is 3, n is 6 here. So definitely it's a. If I do n minus R plus 1, it has to be 6 minus 3 plus 1, which is 4. So it will go down till 4. Here, n is 5, r is 3. See, this position, it will go till n minus r plus 1, which is 5 minus 3 plus 1, which is 3. So, if we generalize this, choose R, I need to permute R from P, it will definitely, it will go till n minus 1, n minus 2, all the way till n minus R plus 1. Now, let's say I'm adding additional factor here. So I'll add this portion. Basically, I'll just multiply a portion with this and then subtract the same from here. So it will remain the same. What I'm doing here, n minus r, then n minus r minus 1, all the way to 1. So, and I need to divide this by this portion, n minus r, n minus r minus 1, n minus r minus 2, 2. So, so this goes n minus 1, n minus 2, all the way till 1. So you can simply write that as n factorial. And in the denominator, what we have, n minus r minus 1, all the way till 1, so which is nothing but n minus r factorial. So it's simple. So we can easily derive how come n permutes r is nothing but n factorial by n minus r factorial. Let's derive this formula a different way. This could be another way of approach this. Let's say I do have n distinct balls and I have r distinct places. So I need to place n distinct balls into r distinct places. How many different ways I can place them? I do have places. So let's say these are the place 1, 2, 3, and so on, so forth. So first place, how many ways I can fill this? I do have n distinct balls. So I can choose n different, any one of the n balls. So I can choose this position in n ways. If the moment I fill first place, so I'm left with n minus 1 distinct balls. So how many ways I can fill second places? Definitely it would be n minus 1 ways. If I fill 2 as well, how many left for place 3? I do have n minus 2. How many places I have? So if I have 4 here, so it has to be n minus 3. So if it's r, what it would be? N minus r plus 1. Yes. Using the counting principle of multiplications, how many different ways I can fill r places with n balls? It definitely has to be n times n minus 1 times n minus 2 times n minus r plus 1. Yes? So again, we'll multiply n minus r, n minus r minus 1, 3, 2, 1. I'll divide this portion, n minus r, n minus r minus 1, 3, 2, 1. And this can be written as n factorial by, and this is n minus r factorial. So this is another way of formulating this NPR. So hope you enjoyed this, and in our next video we'll cover combinations. Thank you.